So today we are going to talk about applications of right triangle trigonometry. And so we're just going to dive right in with an example here. We're going to try to find the length of sides A and B. And of course, this must be a right triangle for us to use our right triangle trig applications. Okay, so we need to find A and B. Now, known things are, we know that this is 28 degrees, right? And we know that this side is 10. So we're going to have to find these two sides separately. And so we want to, let's pick a side. Let's just work with A first, just because it comes first in the alphabet. So I'm going to hide B here. So we want to find a trig function that basically relates this angle with its A is its opposite side, and 10 is its adjacent side. So the trig function that relates both of those would be tangent. And so we know that the tangent of 28 degrees is A over 10. So if I'm solving for A, I multiply both sides by 10, and I get 10 tangent of 28 degrees equals A. And then I can put that in my calculator. Now, be very careful because this particular section is kind of toggles back and forth between degrees and radians. You have to make sure that you're in the right one when you put it in your calculator. Since I'm putting this in degrees, I need to make sure my calculator is in degree mode. And you can change that on Desmos as well. So if I was going to use radians, I would need to multiply 28 degrees by pi over 180 and convert it that way to radians. So since I'm using degrees, I just put my calculator in degree mode. I just put this all in one fell swoop as 210 tangent of 28, and I get A is approximately, I'm going to go out a couple of 3 decimal points here, I get 5.317, okay? All right, so I found the first side. All right, so now I found A, so let's talk about B. Okay, so B, I have 28 degrees. I know that 10 is its adjacent side, and I know that B is its hypotenuse. And so the trig function that relates those 3 items is cosine. So we are going to say the cosine of 28 degrees is equal to 10 over B. All right, so now I need to solve for B, and I'll put it in my calculator. So I multiply both sides by B to get it out of the denominator here. So I get B cosine of 28 degrees equals 10 on this side, and now I'm going to divide by cosine of 28 degrees to get my B alone. And when I put that in my calculator, I get that B is approximately 11.326. Now, this is good. I mean, A seems like my shortest side here, so that's good that it's 5. And I know that this side, right, is always the largest side, the one that's opposite of the hypotenuse, right? So the largest angle has the largest side in between it, right? That just makes, it's just kind of logical sense. So the largest angle gets the longest side, and since this is a 90 degree and these two have to add up to 90, neither one of these can be larger than 90 degrees. So I know that this should be my longest side, and I did get that. I got 11.326, so that does make sense. Now, if you try, I'm not going to go back and check it, but if you want to check yourself, then you can take 10 squared plus this squared, and it should be approximately then B squared, okay? Now, with the decimals, it might be off just a couple tenths or something like that, or hundredths, but it should be close. All right, so a next example. All right, so we want to find the length of side S. So the side S is the full bottom there. And so I have basically one big triangle there broken into 2 other triangles. And I've got the perpendicular bisector in here that I know is 35 feet, okay? So it's not really a perpendicular bisector. I'm just dropping a perpendicular line in here. Okay, so I have 2 right triangles, right? Because if this is, I have the right triangle marked here, but this is a straight line. And if this is 90 degrees, this is kind of going back to your geometry a little bit, then this one also has to be 90 degrees because a straight line is 180 degrees. So I have two right triangles here, both of which I know two things. So I know this and this in this first triangle, and I know this and this in the second bigger triangle. So I'm just going to call these two little sides down here x and y. So s is equal to x plus y. So I can think of them as two separate things. Okay, so let's look at the smaller triangle first. So I need a trig value function that has this angle, this is the opposite side, and this is the adjacent side. So I believe we want to use tangent. Now, you know, there is cotangent, and I tend to look at sine, cosine, and tangent here. And that is primarily because if you look at your calculator, you do not have a cotangent or a cosecant button. And so I tend to use tangent versus cotangent just for that reason. It's because it's easier to put in there. Now there is a button on your calculator that says this, right? And that is the inverse, which we're going to talk about much later. That does not mean the reciprocal. So don't use that button now, okay? So we have tangent of 65 degrees is opposite, 35, over adjacent, which is x. And so I'm going to solve for x the same way that I did the other one. I get x tangent of 65 equals 35. Divide by tangent. Put it in my calculator and approximate it to, let's see, we'll take it out to a couple decimal places at least. And so my x here is about 16.321 feet. Since this 35 is in feet, we're going to say that this is also in feet, okay? So I have x is approximately 16.321 feet. That's just by putting in this. X equals 35 divided by tangent of 65. Okay, so now I can look at the bigger triangle. This is also right? So I can use this. I have this angle. This is its opposite side, which I know. This is the adjacent side that I'm missing, so again, I'm going to use tangent. But this time it's tangent of 40 degrees equals 35 over y in this case. We're going to solve for y. So I'll get y tangent of 40 equals 35 and divide both sides by tangent of 40. I get y is approximately, I'm just putting in 35 divided by tangent of 40, and I am in degrees. If you're not getting the correct answers, then you probably changed. You're not in the right mode. This is 41.711 feet. Okay? All right, so that solves that problem. Oh, maybe one more step. So the whole side S is 16.321 plus 41.711 feet, right, in this case. And when I add them together, I get S is approximately 58.032 feet. Oops, sorry. There you go. Okay. Moving on to the last example here. All right, so this time we have a word problem. We have a 50-foot ladder leaning against the side of a building so that the angle between the ground and the ladder is 65 degrees. How far away from the building is it? Okay, so I know we're going to need a right triangle here. Okay. So I have the angle, let's see, this is the ground, this is the building, and this here is the ladder. All right, now the ladder isn't going to change, so I know that the ladder is 50 feet. Okay, so this is 50 feet. All right, and I know that it says the angle between the ground and the ladder, so that would be this angle here. This is 65 degrees. Now the building up here, it's actually taller than this. Maybe they're working on a window at that height or something. But here's the building, okay? So we want to know how far away from the building is this? And that would be this side over here that I'm just going to call X, okay? So I have this angle, this is the adjacent side that I want to find, and I know the hypotenuse. So that sounds like cosine to me. So cosine of 65 degrees is equal to x over 50. So that means that x is 50 cosine of 65, and I can decimal approximate that and find out that my x is approximately 21.13 feet. Okay, so I found that. Now what if I wanted to know how big or how far up the building, how many feet is this between the ground and the ladder? Like if I fell off, how many feet straight down to the ground is that going to be? Okay, so we'll just call this side y. Since we're here, we might as well do that too. So this time we're just going to ignore x. So this time we have the angle, the opposite side, and the hypotenuse. So that means we have sine. So we're going to use sine of 65 this time, degrees, is equal to y over 50. And so my y is equal to 50 sine of 65 degrees. And putting that all in my calculator and rounding, I get y is approximately 45.31 feet. Okay, so we're not done talking about trigonometry, and so until next time,